Sorry about that. Okay. Hi, my name is Nick. I'm developing team leader in software. Today's presentation is developing a flexible and scalable application. This is the picnic team. There's 9 of us. 5 of us are presenting today. I've got a brief disclaimer.
Do we need to tick the box or anything?
Yeah, you all. I'll come around for you to sign.
All right.
Just that bit. That's nothing worse. But no, we're here. All right. Okay, so here's the agenda. I'm going to introduce the app and the tech. Andrew's going to talk about infrastructure. Then we'll go on to deployment and scalability. Then we'll cover how we do our sort of permission system with Neo4j. And Baz will talk about client-side tech. And then I'll come back in to talk about just general development workflow. Okay, so what do? Picnic is an ISV. We basically have one main application, and it's a workflow collaboration tool. We have partnerships with large businesses, and we operate in the advertising and marketing sector. So that's the domain. The domain's not really that relevant. And our customers are primarily large retailers, so just stores that sell things. Our app boils down to a media library and coordinating inputs into that library and coordinating outputs. So the inputs are photography and illustrations, graphic design, and just keeping people to deadlines to get those things done, and then producing the advertising outputs. The advertising you see everywhere, billboards, catalogs, TV, radio. And the media library was just high resolution files. This is part of our tech stack, but these are the main things. It's not important. We've picked sort of the parts we want to talk about today. There's definitely more fiddlier bits than in here. All right. And then the last thing I wanted to touch on is the sort of the theme of this talk. What we have built and are continuing to build and evolve is a flexible application. So we've made architecture choices to support this. And based on when we started, what we knew we didn't know, and what we didn't know we didn't know. So I was going to allow for questions at each section. So did anyone really want me to clarify something here? Otherwise, at the end of each section, you'll get a chance to talk, to ask something specific to what we just discussed. Okay, so I'll hand over to our solution architect, Andrew.
Hey, cool. I'm Andrew. I'm going to talk primarily about sort of our infrastructure, and then that'll sort of link into what everyone else is going to talk about later on. So all of our production systems are in AWS. When we started developing, we were looking at sort of other data centers and cloud providers. But around the time that we were just starting to get to the end of development for this, AWS launched in Sydney. Most of our customers, all of our customers are in Australia, and most of their users are in Australia, so it needed to be somewhere in Australia for the main data centre, as you didn't have that at the time. And so we've got all of our servers and resources with AWS in Sydney, spread across both of the availability zones. So AWS has about 28, I think now, availability zones, regions around the world. 28 availability zones split across a bit less than half that number of regions. But Sydney has 2 availability zones, so it's split across that to make sure that we're optimal. And we're using, AWS has an enormous array of services and infrastructure that you can put together. We're using probably a pretty standard subset of it at this point. We make a lot of use of S3. Nick mentioned the media library. That's got a lot of small and large assets going into it. Everything from small JPEGs up to large videos. One of the nice things about S3, so S3 is really just file storage. Users are actually able to get pre-authenticated access to our S3, so we can allow you to upload your media straight to S3 with just a browser post. So as far as the user is concerned, they're just uploading a file through their browser, but then go straight to S3 bypassing all of our servers to get the media straight up there. We're also using S3 for things like backups of location. So all that servers back up to S3 and then go out from there. It's a nice spot to dump things. S3 as well is located in Sydney, so they're all located there. But we've put CloudFront in front of it. So CloudFront is AWS's CDN. CloudFront is both a front for our S3 data, so all the media is served from there, which means that for customers who've got employees outside of Australia, they'll get all of their media served from a local distribution point. So even though AWS, for instance, doesn't have a compute centre here in Melbourne, they've got a CloudFront point of presence. So media files are served from somewhere much closer to people. There's many more CloudFront points than there are AWS regions. We also use CloudFront to serve all of our front-end code. So that's coming straight from CloudFront and not from our web servers. We're using Elastic Load Balancer. You can see from the diagram here, that's sitting in front of our web servers. Unfortunately, we're using SignalR and WebSockets, which means it's actually running in TCP mode, so we can't, normally you could put it into HTTP mode and potentially do your SSL termination there, a whole bunch of interesting things, but it's in TCP mode, it's a bit more limited. But it also manages the DNS points to there and then distributes load amongst our web servers. We also actually use that internally. For instance, our RabbitMQ instance is a load balance through a separate Elastic load balancing set of servers. ELB is quite nice in that it does all of the scaling for you. So you basically pay for an Elastic load balancer and it scales with how much is being used. The presumption, I guess, is that you're paying for the services behind it, so Amazon will get their money through that. But it's a piece of thing that you turn it on and you wrap things through it and you don't have to worry about it too much after that. And it will obviously work across both availability zones as well. We're making fairly heavy use of EC2. The rest of the things I'm going to talk about that are part of our infrastructure are all actually just hosted on EC2 instances. So EC2 is sort of the compute part of AWS. So that's where you can just spin up a virtual machine. We've got a mix of Linux and Windows virtual machines. And then they behave just like any other virtual machine. So we're on using IIS for our web services. Nothing very exciting there, so I'll keep moving. We're using RabbitMQ for a bunch of inter-process communication between machines. So we've got a RabbitMQ cluster that spans the two availability zones, and as I mentioned before, load balance with Elastic Load Balancer. We're using Event Store for our main data storage. I gave a talk a couple of months ago about event sourcing, so I won't go into any of that tonight, but there's a video online of my alternative presentation from August or September if you want to know more about event sourcing. We're using RavenDB, again just on an EC2 set of EC2 instances. And it's our main sort of application database, and it also handles search for us. It's got Lucene built into it. So we're able to serve most web requests from there. And we are just starting to add Neo4j to deal with our permissions. Oh, sorry, I should mention, Nick talked about RavenDB at alt.net in February. So there's a video of that online as well. Dave is going to be talking about Neo4j tonight and how we're using that. So just to give an idea about how data sort of flows through our systems, writes coming through our web server, gets written to Event Store. So for those who haven't seen the talk, basically Event Store stores, it's our canonical data store, and we store basically who did what and when in Event Store. And then we have Neo4j and Raven listening to the Event Store and updating the current state of the world as things happen. Dave will explain the arrow between Neo4j and Raven when he does his talk. So writes come in that way through Event Store. Reads are very simple. They just come into IIS basically and read the data either from Neo4j for hierarchical data or RabbitMQ for search and API requests. So one of the things that we've started to move towards is, well, one of the problems we've had is we started to treat our AWS servers a little bit too much like pets and not enough like cattle. So what we're trying to move to is that we've got a couple of services which are deployed and those machines are long-lived. So particularly Event Store, which is our canonical data store, and Rabbit, which is for our messaging. And they'll both be clusters across both availability zones. But what we're looking is moving most of the other servers, all the EC2 instances that we manage ourselves, to be disposable. So we spin them up, they talk just within their availability zone, so that there's a very simple set of connections between them. And then when we have a new version of the code, we will just spin up a whole new set of instances and switch over to the new set and spin down the old set, and that's going to talk much more about that. So that's sort of it from me. Hopefully it's been an okay introduction to sort of how all our pieces of tech fit together, and then everyone's going to jump into the interesting sections of those. So do people have questions at this point?
How it looks like your storage layer is disposable, so RabbitMQ and Neo4j. So how are the stateful things disposable?
Yes, good point. So Event Store is the canonical store of data.
Okay.
So everything that's in Neo4j and Raven can be rebuilt from Event Store. And at the moment that's reasonably quick. So it's very likely that when we get to this model, we're not quite there yet, I've got to admit, that as those instances spin up, they will go to Event Store, rebuild themselves, and that doesn't even matter if it takes a few hours or even a day, potentially. Because sometimes the data structure changes and it's just much easier to reclaim from Event Store. So that's how they become disposable. And they also catch up independently from Event Store in each availability zone in that scenario too. So we no longer need to have a cluster of Neo4j and a cluster of RabbitMQ. Those servers are all independent and they just all subscribe to Event Store. It's a good question.
Yeah. Andrew?
Yeah.
When you said it was reasonably quick,
Yep.
describe reasonable.
So at the moment we're sitting at about an hour.
Okay, how many
It's not
events?
so reasonable.
We're getting close to 1 million. Yeah, so I found it's actually not so much tied to the number of events as, because we're doing batching,
Yeah.
it's more to do with like the number of documents in RAID. That sort of thing, like because you can get through 1,000 events very quickly. If all you're doing is you've got an empty Raven, read 1,000 events and you do one write, that's really quick.
So with the recent issues with Amazon decision being don't be being effective or whatever if you were.
Amazon or Azure?
That was Azure.
There was both.
Oh, right.
I didn't see
Sorry, I didn't know that.
No, I think Azure went on Wednesday and Amazon went on Thursday.
Awesome. We didn't go down because our logging was...
You're lucky, but if you spread across both, or some parts of your system. So how would you ever use this in some form of disaster recovery? So say if Amazon went completely, you could move to a completely different availability zone, or you could get the data out in parts of.
So what we've talked about is having an Event Store cluster node in a different region, which would mean there's a complete copy of the Event Store in another region. And then in that scenario, we'd be able to spin up new instances of all of these in that other region. A copy of the data is already there. We might have to fiddle with our clustering requirements, so tell them explicitly, hey, you're not split brain, it's okay to operate on your own. But in that scenario, absolutely we'd be able to spin it up.
The solutions and the technical decisions you have taken during designing for this solution, was it based on pain points before, or it's just green and you thought, probably this technology is nice, this decision is nice?
Yeah, there's been lots of factors lead to all of the different decisions. Did you have a particular thing you were wondering about? Was it the event sourcing or the disposable things? Or?
the event sourcing mainly because I wanted to know if it really solved a problem that existed or it's just catching up with the new term that's happening in the industry. So because I want to know how valid is the solution compared to the problem.
Yeah, okay. I think we did. It's a long answer. If you have a look at my other talk, I talk for an hour about that. So yeah, I don't want to go into it. Yeah.
Hey, Joseph. I know it's the slide on top, but it's still MySQL. You just access it.
Oh, sorry. MySQL is one of the things we are removing. So at the moment, it's just through RDS instance of MySQL, so it does its own. The RDS, sorry, is the relational data store. So it's sort of a database as a service. Amazon does all of the cross-availability zone failover for you. When we started, we were actually using Hibernate on top of MySQL, and we've ended up using Raven and now Neo4j for that, mainly Raven for that part of it. So MySQL is only used for one small thing at the moment, and it's being replaced shortly. Having RDS is very small now, that doesn't make sense.
That's very honest of you. Most people would just laugh.
Yeah.
It's technically still there.
Yeah. But it's still there. I wanted to. Yeah. It was in our list of what servers we've got. Yeah.
You talk about making your services immutable. What are you doing to actually make them immutable? What frameworks are you setting up, such as Docker or Puppet, Chef?
Oh, so Matt's going to talk using Chef.
Yep.
And Matt's going to talk about Puppet.
Okay.
What do you use for persistence for your RabbitMQ?
So that's just on an EBS image. I think we've got. Sorry. Are they on SSD?
Yeah.
Yeah. So they're just SSD backed. Most of our Rabbit stuff, I mean, we've set up all the high availability during compute, but most things are on Rabbit for a very short amount of time. The kind of processing we're doing now. So we've had a bunch of things that were going over Rabbit and are now just event store. So Rabbit over time, that's what we do use Rabbit for, but Rabbit is used less and less over time as event stores become more and more a core part of it.
I want to add, we definitely did pick certain tech because it was interesting. So Event Store is possibly the example of that. But other technology choices were made out of pain points. And this is the sort of the phasing them out. So the MySQL is being phased out because it is a little bit of a pain point to manage. So that's why we didn't talk to it, but it's going away and it's about to go away. So in Hibernate, and we had SQL Server before we had MySQL, that's gone away as well. So that was replaced with Raven. Event Store came in out of interest, but also we were doing sort of a CQRS approach, so command, query, response, segmentation. Is that right? Yeah. So we did have commands and events prior to having an event store. So that's how we sort of designed it originally, and that was all going over Rabbit. So then it was to phase out the commands, and it was to phase out the events being sort of these transient things, and keeping them in the event store. And the event store was it wasn't like an unplanned or not a prepared for choice. It was made because we knew we would have customers whose requirements would evolve, and because this sort of the sector we're in, because we were targeting businesses that were not using our app yet, we wanted to be able to sort of rebuild the application, grow the application more naturally. So, and that's how we achieve sort of the throwaway persistence layer with Raven, so we can just replay it. This sort of the being able to throw away those instances, that's a current pain point for us, because right now to sort of roll out a new version, we have to sort of take the application offline and replay these things because we don't have this capability. So we're quite close to being able to do this, what Andrew discussed, where we've got sort of another instance run, another set of these servers running, and then we switch them, which Matt's about to talk to now. So I'll hand
And plus we're on the first slide.
So, hi everyone, I'm Matt. I'm going to talk to you about our deployment and how we're scaling our application. So as Brownie talked about, our server infrastructure is AWS, and as we mentioned, it's largely a manual affair at the moment. We're very close to getting it fully automated. Our configuration management is done with Chef, and for deploying our application, we use a combination of Team City and Octopus. Chef, I like this quote from Abraham Lincoln: "Give me 6 hours to chop down a tree and I'll spend the first hour sharpening the axe," because writing Chef recipes and cookbooks is a real pain. But once you've done it and you've had them all tested, you realise why you do it, because you can deploy a server in a couple of minutes. And it's always the same and it always works. So Chef, I think we chose it was a long time ago. I think we chose it because at the time Puppet didn't have, wasn't able to deploy to Windows. Don't quote me on that, I'm not sure. Yeah, so each node's in an environment. They perform a role. Each role has running one or more recipes, and recipes are stored in cookbooks. Everything in Chef is a text file basically, so you can keep it all in Git, all your cookbooks, all your environment configurations, all your role configurations, and you can also keep a Chef server configuration in Git as well. It allows you to recover quite quickly from disaster. Octopus deploy. So we use this for our code deployments. It's Windows only at the moment. I understand that Linux tentacles are coming soon. I'm not sure when. It has the same kind of concept as Chef with environments and roles, and you configure it with apps, and you take snapshots of those apps which are releases. So each app has a deployment process. It's a list of steps that happen. Some steps you can say only happen on certain environments, that sort of thing. But basically what happens is we'll retrieve Git packages from our Team City installation, and it has variables that are associated with the application, and they can be applied at the role level and the environment level. And so the variable snapshot plus the Git packages equals the relay. So you can store things like connection strings and secrets in variables. The kinds of steps that you can have, you can deploy an iOS website, Windows service. There are other steps available as well. PowerShell steps we use a lot. Just basically executing random hooks, not random ones, but the hooks that are appropriate to our build process, that sort of thing. You can do partial deploys. You don't have to deploy everything every time. You just fix a spelling mistake in HTML file. You can just deploy it to your web service. And you can also do rolling deploys. We don't, but the feature is there if you need it. It's easy to roll back generally. You just redeploy the last working release. Of course, that doesn't apply when you do things like large data changes and things like that. But for code-only changes, it works. So as Brownie was talking about, this is where we want to be very soon, delivering deployments. The concept is that we use Asgard to manage our AWS infrastructure. So we bring up a new copy of our production infrastructure with Asgard. We automatically bootstrap all of the instances with Chef and Octopus. Chef and Octopus can both do full deploys. It's smoke tested. Then we add the green web service to the load balancer, take out the old ones, and then once everything's all running, we tear down the blue one with Asgard. So that's basically our deployment process. I'm going to talk now about basically our messaging system. Our requirements when we were choosing it were those mainly reliable and easy to manage. Also easy to use. Didn't want developers spending a lot of time on it, and low latency was, of lower importance, but we didn't want it noticeably slowing down the application. This is what we looked at 2 years ago. We looked at in-service bus, mass transit, and RabbitMQ and EasyNetQ. Initially we had RabbitMQ and we wrote our own client. That ended up being a bad idea. It got too complicated. We found EasyNetQ and it just fit really well. So yeah, we chose RabbitMQ after all of that. It's written in Erlang. It's maintained by Pivotal. It runs pretty much exactly the same on Linux and Windows. It's very easy to administer. It has a web console that you can go to if you install the plugin. There's a command line that can let you control the servers and the clustering, and all the configuration is in JSON. So it's very easy to deploy. It supports clustering and failover. We're using durable and highly available queues. You don't have to if you don't want to. It's a bit faster if you don't. Can guarantee at least once delivery. It has various types of exchanges, direct fan out on topic. And it supports virtual partitioning for virtual hosts. And it also supports federation shuffling, where you can federate exchanges to other exchanges in other clusters. So you could have another cluster in another Amazon region if you wanted. Right, so our setup is a cluster of, as Brownie said, it's a cluster of RabbitMQ, OneELB in the two AZs in Sydney. You can use hard proxy, that's really well documented and works really well. We just didn't have any need for it in production. We used Mike Tadlow's EasyNetQ library. Handles all the RabbitMQ stuff, and yeah, we don't even touch that anymore. We hardly even think about Rabbit and EasyNetQ. So use cases. First one is the scaling of our long-running CPU and I/O operations. So things like file format conversion, videos can take a while, zip bundling, and producing PDF and InDesign files, that sort of thing. We use a topic exchange. We've only got one topic at the moment, but the way the topics work with their namespace style, you could say have certain servers subscribe to a certain portion of the topic and other servers subscribe to other portions of the topic based on SLA or licenses that you might have, that sort of thing. Subscribers are round robin by the broker, so one message gets delivered to this guy, one message gets delivered to this guy. They are isolated, they don't know about each other, there's no clustering. So scaling, you just bring up new instances, they connect to the broker, they start receiving jobs. The redundancy is provided by the multiple AZs, and this has worked really well for us over the last 2 years. The second use case is basically distribution of messages to signal our clients. So in-app notifications and progress, that sort of thing. When you're, say for example, when you're converting a file, it can take quite a while and you want to be notified, when it's going to be finished and how long it's taking. So each web server receives all the messages that go over this exchange, and the messages are delivered to users and groups via SignalR. If a web server receives a message for which it doesn't have a user or a group attached, you can just drop the message. And that's it. Got any questions?
What were the problems you ran into when you wrote your own library for Rabbit?
Naivety.
Yeah, I guess we'd never done it before, and we're also new to the message broker concept as well. So we wrote really complicated reconnection logic and things like that to make sure that we didn't lose messages. And then when we saw EasyNetQ, we just went, this is rubbish, we'll just go with that. So Andrew's actually submitted a couple of pull requests to that project too. I think one thing was fair work queuing that we needed that didn't have, and so he's done that. So we, from time to time contribute to it, but really, I don't think we've really needed anything new.
That was a better way to get what you needed.
It was, yeah. Unfortunately, I wrote the previous.
Well, no,
I didn't mean you when I asked the question, I meant you.
Well, we took 3 stabs at it. Matt wrote the first one, then
Yeah.
I did some extra changes, and then Andrew joined us at that time. And
Yeah.
did the other round, and then we realised
You all failed.
This is too hard. Well, we were basically reproducing something that existed at that point. Yeah, we did fail. Yeah.
How long does it take you to get something from coding out to production through that process?
I can talk about that.
Actually, Nick's got that in his process. So,
Or ask it again later.
it depends.
What do you use to orchestrate multiple servers since you're using shift deployment for each particular server configuration? What are you using to connect them? Are you ground formation?
Oh, no, we're not. No, that's where we're trying to get to with the Asgard thing. So Asgard provides an interface to CloudFormation configuration. So no, we're doing everything manually at the moment. We just bring up new ones when we need them, and then we take them down as file size.
How do you test your chef recipes at the moment?
We have an internal server that we just bring up VMware instances on, test them, make sure it all works, and then once that's right, then we'll bring up an instance in AWS, deploy it there, make sure everything works. That's basically it.
So once you've got the green deployment, you can still use Octopus to deploy, or will the humanity coming after the fact?
I'm pretty sure we'll still use Octopus, so they'll just bootstrap themselves, and eventually they'll come up. I mean, depending on the instance, it takes between say 5 minutes to an hour to build a new instance with all the things we have to install on it, especially Windows ones. So I'd say having Octopus as a step at the end of that, where it just pulls the code it needs for the roles, that's not really long. Like it's not a really big time saver in the grand scheme of things.
Do you have secrets and passwords in your front scripts, or is this all managed by the shared file?
They are in Octopus, so no, we don't keep the secrets from Chef. Except for some, the ones on the Linux boxes, they're in the database.
What about pre-baking AIs, so you don't take that one?
We do that for some things. It's still the future at the moment for me for this new way of doing things. But yeah, so say our VPN servers, for example, they're all pre-baked. So if they go down, we can bring out new ones.
How do you do your tenanting?
In the app.
Yeah. Having the storage and the queues, and is it all just mingled together, or?
Okay, so with Rabbit, there's the vhost feature. So you connect new connection string, you connect to a vhost. So the stuff that's to do just with the app and say like the SignalR stuff that I talked about before, that's in one vhost. But then our media conversions, that's all in another vhost. It uses a slightly older version of our client stuff, and so it talks a slightly different language, so to speak. And so we keep them separate. So that's how we do that. But with the app itself, it's basically all tenanted in Raven at this point. There is no multi-tenancy supported event storage at the moment. I think that may be coming. It's on the radar.
Isolation.
Yeah. So we isolate the streams by appending the tenancy name to the front of the stream. Yeah, we parse that name. Yeah. Any other questions at all? Okay. I think Dave's next.
I started thinking about sequence work, and it's been lots of fun stuff. So I'm going to talk about our permission system, which sort of motivates why we're moving to Neo4j. So I'll talk a bit about how we model permissions and how we currently implement them, and then go on to talk just briefly about Neo4j, which is a graph database, if you don't know. So like any permissions, really permissions are just tokens. every entity in the system is identified by the GUID, so we've got folders, jobs like approval jobs, all sorts of different entities. Each one has a GUID. The permissions are a combination of the GUID and the roles. So, for instance, you might have write permission on a folder. You might also have read permission on a folder. So these are how we distinguish our permissions. Each user has a set of permissions, and a permission check is simply, for this current user, is the permission I need in the set of permissions I have. So you could just store the permissions as a list or a set. We need a little bit more information because, as mentioned, we've got the media library, so there's a set of folders. They can inherit permissions down the tree. We want to be able to store relationships like that in the permission system. So we actually represent it as a graph. Each user starts out with a single permission in their set of permissions, which we sort of have this pseudo role called me. And then to add a permission, as events come in through the event sourcing system, we have a configuration which describes when this event comes in. We may add a particular relationship, like in this case, it might have been an approval job was created, and so the current user then gets ownership permission on the approval job. So that configuration just works with the event sourcing to build up the permission graph. We don't just, as I sort of mentioned, we don't have just relationships between the me permission and actual permissions. We also have permissions elsewhere in the graph. So if you had write permission on a folder, it might also imply you have read permission on that folder. So we can represent that with a relationship between the write and the read permission. And then checking for a permission isn't just checking for something in a set, it's checking whether whether there's a path in the graph from the user's me node to the permission that you're interested in. So in this case, you can see there's no path between the me and the read permission, so this user doesn't have read permission. If another event comes along, introduces a new relationship where that user has now got write permission on the folder, and we want to check whether they have read permission, now we can see that they do because there's a path through the graph to that user. So it's quite a general way to store our permissions, which we've found in practice works quite well. The original implementation of this was done in Raven, which is just, it speaks to this development process where, we didn't introduce an extra dependency just because it sort of seemed like we could do it in Raven, we didn't want to add extra services on top. And so it was initially built in Raven, and the way it was built was each node in the permission graph has a document in Raven, and that basically just lists which other permissions inherit that permission. So you can see from this graph the read permission is inherited by the write. So if you have write, then you have read. So the read permission is inherited by the write permission. The write permission is inherited by me, and own is inherited by me. So we have this little graph. Obviously, these are lists. So you have multiple permissions depending on the incoming relationships into a given node. You can't query this directly, obviously, because if you want to know, does this user have the read permission? And I just look at this read document. All I see there is the write permission, and so it seems like they don't have the read permission. So on top of these documents, we have a background work task, which runs through these initial, store the actual relationships between the nodes, and builds up a second state document for each node, which lists all of the permissions that are inherited for a given permission. So here, the only change for this graph, because it's so simple, is that the me now appears in the read document. So now we can query the read document and see that user has in fact has a permission. This is sort of just an iterative process over all of the documents. We have Raven indexes which identify which nodes need to be updated as new changes come into the graph. And so basically that will build up the, in original document for the right permission, we build a state document for the right permission, which will initially, sorry, I should say the read permission for the original document. We build the initial state document, which will just have the right permission in it. The right document will have just the me permission in. Then our index worker will go over this and see that read is connected to write, and write has this extra permission in that we don't have in the read state document, and so it'll insert that into the read state document, and just iteratively builds the state documents until the graph is settled and there's no more changes. So then it can query it just by checking whether the me sort of pseudo permission appears in the set. So this obviously has a number of issues. The main one is that this work process can take a long time, and so there's a period of time where permissions aren't quite in sync. It hasn't been a huge problem, but there certainly are issues, and to address that, what we've had to do is build a sort of cache permission graph in process that updates in parallel with the permission graph that's stored in Raven, which sort of ameliorates some of those problems, but still, if there's sort of the other processes we've got, running don't necessarily have those permission updates, so there's still issues there. The first point there is the state documents can get very large. Basically, the nodes, the permissions at the very end of the paths end up with everything all the way up. We sort of work around that by introducing intermediate groups. So certain nodes, sort of, if you imagine the users are sort of down the bottom and the end permissions are at the top, we mark certain nodes in the middle as group nodes. Then we record which users belong to which groups and which groups have which permissions, which sort of produces what we need to store in the middle of the graph, and then see whether if there's an intersection between whether a user belongs in a group that has that permission and do the permission check that way. But yeah, we still have problems where occasionally there's permissions take a short while to catch up after some changes have been made, which means the user may not see something they should be able to see, or vice versa, probably worse. So the obvious solution to this now is to just use a graph database where we can store the permission graph as a graph instead of trying to mash it into a document store. So that's what we're working on at the moment, and that's what we're introducing Neo4j. And so this Neo4j does exactly that. Instead of having documents storing sort of a bag of properties, you have nodes in a graph and relationships in a graph connecting them. The nodes can have types or labels, so we have permissions and users and groups. And the relationships can have types. We only use one type at the moment, which has permission, which is basically just the graph it's looking for. So the advantages are numerous. You get transactional updates. So as soon as you insert a new relationship into the graph, the next query you make will show that update reflected in what permissions you have. We no longer need to calculate the intermediate state in the state graph. We're hoping it's faster. It hasn't been proven yet. It's still being implemented. And importantly, it's a lot simpler as well. So this background working task that scanned over the permission nodes and built up the state documents is a relatively complex piece of code and doing stuff in Raven that we probably shouldn't be doing. So this is quite nice. There is one caveat, which is that we do need to send some data still back into Raven. We use permissions in two main ways. One is that each API endpoint can be decorated with a requires permission attribute, which indicates that in order to access that endpoint you have to have a certain permission. We also use it though in our search results. So most users in the system have access to search for various things, for the media library and various things. In those search results, we only want to return results that you actually have access to. But in order to do the search, we want to make use of Raven's indexes. So we need to insert or some form of permission information into the Raven indexes as well. And that was the arrow, if you remember way back when, going back from Neo4j into Raven, that Andrew spoke about earlier in the talk. But sort of one very nice thing, I'll just is that it also gives us the ability to visualizations. This is built into Neo4j's web client that you can use to play around with the graph database. So this is actually just an example of our actual permission data from a test database. It's a bit hard to see, but each node is a permission. They're not labelled, so they have the keywords and the roles. And the arrows are the has permissions relationship. So it's sort of, yeah, get an idea. And it's quite nice for debugging to see things are doing what you're expecting. Yeah, so that's the motivation behind why we're doing it today. Are there any questions?
Does that have its own query language?
Yeah, it does. So we've only just started using it. It seems like it's gone through a few iterations. The earlier iterations had a query language called Gremlin, which seems to be a general graph query language where you define a traversal of a graph. So you want to start at a particular node and then follow certain paths. The newer version, so version 2, I think they introduced it, has a language called Cypher, which is quite declarative. You basically can match nodes on certain properties like a label or a property that the node has. And I don't have an example of the syntax, but the syntax is sort of, a bracketed node with parameters to match the node on, and then just ASCII arrow, which represents a relationship. You can have an arrowhead to indicate the direction of the relationship, and probably like a relationship type, for instance. So you basically end up with queries that look kind of like the graph, the skeleton that you want to match. You can pull the results out from that. So it's quite nice. Yeah.
How do you go about, if you wanted to execute a query, for example, or get all of the people whose name is John, who I have permission to read, could you execute such a query, given that the permissions are in an entirely different database?
It's all the people who've come before. I try to understand.
So if you wanted to say execute a query on your database, get all the, and I don't know what these entities are that you're giving permissions to. Let's say that they're customer record. Give me all the customers named John.
Yeah, I see. Yeah.
Who I have permission to read. Can you execute such a query, or do you have to or are they two separate queries?
We'd have to chain that together in order to do that efficiently. It's sort of not a need we have, so we haven't really considered it, I guess. Except for it ties in a little bit with the searching, where we have to project some data back into the Raven database. So we could do something similar to that. Otherwise, it would probably be you really build up the graph based on the queries you want to make. So the design of the permission graph is really that we have now is based on the kind of permission queries we need to do. But in that case, you would probably also introduce that name property, say, into the permission graph itself somehow with a separate relationship, and then you could just do that direct query on that.
Yeah. Have you come across the need, or have you thought about the need of explicitly denying access to a permission? Because if at some point, probably in your route to the permission, sometimes you probably need a specific scenario that goes through the same route, but for a specific entity that, no, for this one, explicitly denied access.
Yeah, I can see your point. We haven't had that need either, but that would be quite simple to add just by adding an additional relationship saying that this user does not have this permission, which you could check first. Yeah.
Yeah, by default, no one has access to anything.
Sorry, yeah.
That's how we avoid denies right now.
Yeah. So, I think ever since I started computing being programming, I've pretty well written a user role permission system about every 2 or 3 years. So what was it like doing it in the N4J compared to doing it in all the other ones you've probably done in the past as well?
I haven't actually had that much experience with it. My previous job was building a network game client stack, which didn't have need for that. But I can compare it between the Raven system and what I've just done with Neo4j, and it was far simpler. biggest, the sort of the thing that's taken the most time in implementing this was understanding the existing Raven implementation of it. But the Neo4j system sort of wanted to, because it's a much, you know, the graph is just the graph.
I know what you mean, 'cause the Raven thing, as soon as you described it, it sounded like a smell of horror.
Yeah, which basically, you know, is sort of there for historical reasons, but yeah, it wasn't a solution. So, it just, you know, what we actually need is a permission graph, and now what we have is a graph database to store that graph, and it, you know, there's a one-to-one match between the two. So yeah, I would say it's a lot easier.
And to add to that, Neo4j is the third iteration of permissions. Raven's the second. The first was much simpler. That was, I don't want to say.
I believe it's MySQL.
Yeah. We'll talk later.
What's the information you actually inject in
so blue filters are something we're considering to introduce along with these changes now. The existing solution is the kind of groups when I was talking about the state documents end up with too much information in them. We introduce these intermediate groups. What we project is, so we know which permission we need to see these documents. So when we build the index, we find out which groups have that permission, and we store that in the index. And then we make the query, we find out which groups the user belongs to, and send over the query and ensure there's some intersection there. Yeah. But yeah, we're looking at moving to simplify that. At the moment, we've got to pick which nodes we want to turn into groups, but which is the main task. I think it's Basarat next if we're.
Yeah, thanks. Okay, so I'm mostly going to be talking about the frameworks that we have in our front end and give you a few tips along the way if you're going to be working with these frameworks. So we're using TypeScript as our front end scripting language instead of JavaScript. It's basically just JavaScript with types and the future JavaScript. And when I say the future JavaScript, I basically mean it has classes and lambdas, which means that if you're familiar with the concept of MVC, your controllers can be just classes and not something that you make out of functions. And with lambdas, what it does is that it really removes the function keyword. For a functional language, you seem to be writing the word function quite a lot in raw JavaScript, and with TypeScript, you don't need to do that. You can use the lambda syntax. And it also lexically scopes this. For those that are familiar with JavaScript and the contours of this, TypeScript helps you a bit there. And it has types. So it's a feature of JavaScript, and it has types. And what types give you is discoverability. You know at this point that this particular item over here, which is file, has these members on it, and you know for sure that it has these members on it. This is not based on some random code analysis that something like Sharper did that. I know that this name is in some JavaScript file. I think you might have that as a member of this particular variable. So this is actual proper code completion if you're familiar from other static languages. It gives you refactoring support, and again, the refactoring is reliable. It's not going to be, I think this variable is that variable of type, so maybe if you rename this, maybe you want to rename that. And this code completion and refactoring is not just for our client-side TypeScript. It also extends from the server to our client-side TypeScript, in that we generate DTOs, which is basically the data transfer objects between the server and the client as interfaces in TypeScript, which means, in addition to this particular data structure, or what particular data structure we're going to be passing, we also generate the services. So you never need to actually make an XHR call yourself. These functions will be generated for you in our code base, which means that someone's alarm is going off. So, I'm sorry. So, for making you awkward, whoever that was. So the create related function basically is generated, so the members of that are defined. It's going to be reliable, it's going to be type safe. You refactor your backend, your client-side code is automatically going to change, and you're going to get compiler errors.
which is exactly what is happening over here. We modified assets to be stem items because it can be assets or products, and our client side code gives us an error that this particular thing no longer has an asset ID, it has an ID, we factor it. Now if you want to use TypeScript in your projects, you don't have, it's not an all or nothing proposition, you don't need to read all your JavaScript code and go with TypeScript. You can introduce it partially, just rename your JavaScript file to a TypeScript file, and it's most probably going to say that it's bad. You haven't declared your variables, you've assigned something to a string, and then you've tried to assign it to a number, and that's just the compiler helping you, don't swear at it. You can use JavaScript code from TypeScript quite easily as well. In fact, there's a bunch of these definitions. Basically, you declare what is the ambient environment in which your TypeScript is going to be running. For example, for jQuery, there's the $ variable, which has a number of members on it. So you bring in the jQuery definition, and it knows that, okay, so there's, if you're using $, it can be a selector, it has these members on it, and blah, blah, blah. And this repository is actually becoming the de facto repository for all client-side type definitions. So WebStorm uses it for, even if you're using JavaScript, Node.js, Mocha, this is the definition file that you'll be using. If you're going to be using Flow, which is the statically typed language from Facebook, which is syntax compatible with TypeScript. And there's a reason why all of these languages, and the next version of Angular is going to be written in AdScript, which is also another version of typed JavaScript. The reason why all of these are actually compatible with TypeScript is mostly because of this, and secondly because TypeScript itself is compatible with the type annotations that were introduced with ECMAScript 4, which never made it off the shelf. And a couple of tips that I have is use require.js. The reason why this will help you is it will allow you to compile your TypeScript for the client side with require.js, as well as with the AMD module pattern for those that are familiar, as well as for the server with common.js. If you have questions about these, you are free to ask them at the end of this talk. The next client-side technology that I'm going to be talking about is AngularJS. The main reason why we went with AngularJS as compared to its alternatives is because it's full stack. We had Knockout in our previous project, which meant that for something like history, we had to use history.js and bootstrap a bunch of stuff. With AngularJS, it's full stack, just bring it in, start using it. This is the point where we were making our decision. We're really glad that we went with AngularJS at that point, because everything else feels like the lonely island. So another great thing about TypeScript, about AngularJS, is that it works really well with TypeScript. It really doesn't impose any restrictions on what you're going to be using as your model. I showed you the controller, which is just a simple class. AngularJS is great for TypeScript. So this is that same template introduced over here as well. So we have these templates in our wiki, and anybody who wants to create a new controller, he just copies this file into a new folder. And the reason why we have them in the wiki is because you can use Visual Studio, Sublime Text, whatever you want to use. You make your own templates. And the services are even simpler, it's just a simple path. For those that are familiar with AngularJS, the $inject is actually right next to the constructor, which means that they rarely get out of sync. So our code works with minification as well, and it doesn't look ugly, which it does sometimes with raw JavaScript AngularJS. We don't absolutely love it. We're not fanboys of AngularJS. The DI is good, but it's actually not that required. The reason why we have to use DI, Angular's dependency injection, is because to get access to stuff like the scope or its own services like timeout, etc., you need to use its DI mechanism, which means that you have require.js as well as Angular's DI within your application. This is being fixed in the next version of Angular anyways. They're going to go with the standard ECMAScript 6 syntax, which brings me to AdScript, which is the next version of, which is the language in which the next version of AngularJS is going to be written in. It is type compatible, it is compilation compatible with TypeScript. So this is basically valid TypeScript code as well as valid AdScript code. And just another little tip to make your time here worthwhile. To manage links within your application, you can use something like this, which is what we use, which is just a simple JavaScript object which has a number of member functions on it. These member functions are just lambdas, which is another great thing about TypeScript. What this allows you to do is if you expose this particular entire DTO, this entire JavaScript object as a member called link2 on the root scope. Within your HTML, you can just simply do link2.job.editCatalog and blah, blah, blah. So this makes your URLs within your entire application consistent. And we actually use the same JavaScript object for configuration as well, configuring the routes within our application, so it never goes out of sync. And here's another tip for, because we drive everything within our HTML from our controllers at every single previous job, inevitably at some point in the bug you have to click 10 times just to get to the bug. You can mostly do those things directly from the controller if you write your controllers properly with AngularJS. Okay, so we're using TypeScript, we're using AngularJS, we're using Sass for our CSS. We did evaluate other options. At that point, Stylus was not that up to date, and we didn't like the functional in the sense of non-imperative functional. Functional is good, but lack of imperative ability made not such a good option at that point. So we went with Sass. Plus, a number of other community members also went with the same decision. So to compile our Sass to CSS or TypeScript to JavaScript, and then merging all these JavaScript files and these CSS files into a single minified one and sending it to the client, that's managed by Grunt. It does that on our build server as well as at dev time. It watches your files whenever you make modification. It regenerates the CSS and JavaScript, so you can just, by the time you make your modification, save it, go to your browser tab and F5 it, it's mostly ready. Or you can have a sip of coffee if it's not. One tip that we have with Grunt is that if you're going to be using it, check in your node_modules folder. For those that are familiar with Node.js, this is where the node modules that your application depends on are stored in. You could put all the configuration of all the modules that your application depends upon in a package.json and do a simple npm install and it will fetch those for you. But it will be a problem if npm is down. It will be a time-consuming task for every new dev machine. It will be a time-consuming task on the build server. Just check it in and not worry about it. Plus, the guy who checks it in gets the greatest number of code line changes in the repository. So that's good. So you're keep it off. That's Nick, by the way. Mocha is what we use for our front-end testing. The two main options were Mocha and Jasmine when we evaluated it. They still are. The reason why we went with Mocha is because of its excellent support for async tests. And if you're going to be writing JavaScript, it's always going to be async. It's always single-threaded on the server as well as on the client. So this is a sample spec in Mocha. We have a simple test over here. And what makes this particular test async is the fact that we're going to be returning a promise. So if you want to learn more about promises, talk to me afterwards or ask me a quick question if you have it. You can manage to ask it from this code sample. So this entire test is going to fail if any part of this promise chain fails, or this test is going to succeed if it succeeds. Mocha does it silently, which is excellent. AngularJS loves promises as well, so it's really just extremely simple to merge together. A couple of other tips that we have over here is that isolate your create functions, your get functions, and your expectation functions, just because you're going to be using them in a bunch of functions, and you can do more tests that way, and your test spec looks cleaner. And so if you want to use Mocha, so we looked at the built-in tools that come with Angular, like Karma and now Protector, etc. We don't actually really need something like that. We don't need something that heavy, and we didn't want to manage, because once you do that, you need to manage the versions between the two as well and keep them in sync. Otherwise, Karma doesn't like the current version of Angular you have and stuff like that. What we've done is we've abstracted away the Angular side of our client-side code. So all of our HTTP services are generated, which I already mentioned, which means that their only dependency is on $HTTP. So we can mock out physical $HTTP with the request NPM package. And so what we're doing with our Mocha tests is we're testing everything from the client-side JavaScript up to the backend, which means that if we so there are going to be actual HTTP requests to the server in our Mocha tests. The reason why we did this is this ensures that if we have an issue, is that issue in the back end or in the front end client side code? It was really important when we were making massive changes. Plus, it allowed Andrew to completely rewrite the back end, and whenever he does a refactor, which is probably what he's going to be doing with Stranding as well, he can just run the Mocha test, and if they work, he knows that he hasn't broken anything in the back end. And the client side is going to be completely happy with this. So this particular code segment is going to be generated. All that it depends upon from Angular is something like $HTTP, the promise library queue, something like the timeout service, or whatever. These can be mocked out quite easily in Node.js, and that's what we've done. One little tip is store your common logins in a simple JavaScript object. These are your test logins. I've changed the password for these test logins as well, although you could probably guess the actual one as well. And that's pretty much it. So any questions? You can talk to me afterwards as well. That's it. Go for it.
You said you used Grunt to minify and work with your resources?
Yep.
How do you manage this between development environment and production?
So we have within our index.html, which is the main page that you serve when you're making a single page application, which is actually going to bring in everything else. We have a switch there that if it is a debug build or a release build, if it's a release build, then it just requests the minified versions within an include. Now these minified versions are going to be generated from Grunt. If it's not, then it's going to simply make a require JS call with the data-main and require the main JS file, and that's going to bring in the other files. So you get, in your Chrome debug tools, you get all the JS files with all the CSS files.
Alright, so I know it's pretty hot in here. I think we've just got Nick left now. Got a choice. The pieces are here. We can take a break and move out in the other room for a little bit and cool down, or we can just try and get through Nick's and then feature afterwards.
We've been working with feature branches for a while, and just quite recently we started going down a pull request kind of workflow, and I'll dig into that. So about 2 months ago, just over 2 months ago, we put up with some guys back there, Adam and Michael, who recommended an approach to us in a much longer, more detailed discussion. So 2 months has passed now, and I want to sort of give a reflection on this as well. We've closed about 120 pull requests. There's maybe 8 open, like at the end of the day today. So how are we doing it? We were using feature branches earlier. We would branch off of master when we were developing a new feature. We would either throw the whole dev team at it, or some of us, depending on who needed it and when and why. Yeah, prior to this workflow, it was a little bit, cowboyish. Everyone just, first one to push gets to trigger the build server, often it's Baz. And then, if someone else happened to fetch at that time, for whatever reason, it may be in a bad state. Just by the nature of our build server taking a few minutes to do the build and the tests. So the new approach is we branch off on a feature branch, and then each developer, typically one person per pull request, has a isolated thing to work on. The developer gets to create the pull request whenever they like. They can create it at the start or when they think they're ready for someone to review it. If they create it early or whatever point, you can do tagging through the GitHub UI. So we're using GitHub to help us with this. And we were using GitHub before this as well. And Team City helps with this. The other how part of this that I want to introduce here is the pull requests are asynchronous. And it is a little bit of a, it's asynchronous in terms of who you want to review it. You don't need to go and interrupt someone to say, hey, can you please review my pull request? So if you do need to, that's okay as well. But it's really, hey, when you're ready, have a look at it. Okay, so that's the introduction. Here are the GitHub tags that I alluded to. We had 3 up until today, and then I introduced a 4th one, which is in progress. LGTM means looks good to me. So it's either you flag it ready for review, and you tag someone. If you just mention their name in GitHub, they'll get an email notification. And we've got other sort of configuration tools plugged into this. Sorry, but other services plugged into this to help deliver notifications, like our team chat Slack. So certain messages come out of GitHub. and our other services like Team City or Octopus that alert us. And then yeah, just Team City is building these pull requests. So I'll talk about the why first, and so I'll stay on track. Why? We touched on this. Adam and Mike recommended it to us, but the reason we jumped on board quickly with this was we wanted more code reviews. We were struggling to do code reviews in a sort of consistent and a frequent manner. I don't know, that's possibly the case in lots of places. And from the code reviews, we were trying to improve our code quality just by having another set of eyes on the code earlier, and that leads to catching bugs earlier as well. And we also wanted to share knowledge as well. Being a small dev team, and especially if we're working on a few things, it's quite easy to develop little silos of, hey, just this person's worked on this. At least with a code review, at least one other person has seen some of this stuff. So here's an example of a bug we caught. Lucky he's left. In this case, this was the code I was reviewing. It was quite nested in a lot of changes in this one. Just the nature of this change meant that there was 5,000 additions. It was mostly config and packages changes, and some deletions as well. But there was if you can see this here, there's a throw. There's a deliberate throw left in some code. This is because we were changing our logging system and we wanted to see that it was actually going to catch an exception and not try to have to, actually cause a real exception in the app. But yeah, this, at the time this landed on my desk, this needed to be reviewed. This was still in there. So if there was a few issues, you just make some comments, or you just tap the person on the shoulder and say, I think you left some code in. Commit. They either amend that commit, because it's your own branch, you can force push over it quite easy, knowing there's not going to be a problem, or just have another commit that corrects the thing. And then, because the build server would not have caught, this is a runtime exception, and none of our tests would have caught this as well, because we're not testing at, this is like right at the top level of hosting our application. Yeah, at the service level. So there's no test set. Yeah, there was some weird behavior if this went in. Okay, so the wins that I can talk about already is the build server is far more often in a green state. This allowed each developer to rely more on the build server. So with Team City, we just set up a few more agents now that we have a few more builds happening. So now you can actually, if you know your pull request is not ready, you can push more often and push somewhere where a build will be triggered, and you can sort of lean on the build server to help detect things. So in our code base, there's a bunch of tests that will run on the build server, and some tests that you don't want to run too often on your dev locally while you're working on something. So it'll capture that well before it gets, before it bothers anyone else. I touched on the knowledge sharing already, and the silos, reducing that. And just, it's an opportunity to have sort of constructive feedback chats as well. Like, hey, I think you could do this a little bit better. Or, oh no, we already kind of solved this problem here. This is better. Or, yeah, things like that. Yeah, and I've already mentioned the bugs. Okay, so there's the testing part of this I've also already mentioned, but basically our unit integration tests run on Team City this way. We have another integration point with our bug tracker where particular commits, if they're flagged correctly, can update the actual bug. So you don't even have to mark the bug as finished. We'll have a suffix on the end of a code commit check-in message, and it will just update our bug tracker with the build where this bug is fixed. So that helps the testing team as well know that, oh, is this actually, I know the developer, this way the developer didn't have to mark it as fixed. The pipeline did that. And then we just have to check that, is this build released into one of our testing or staging environments, and we're good to go. Yeah, so this is a little bit what the Team City build integration looks like in terms of GitHub. It says, it just adds comments, hey, I built this thing, took this long, these are the tests I run, and it was successful, or it failed. And then for the person reviewing the pull request, they get the nice green button already when we know that the code in this pull request merges against the branch they forked off of, plus the report from Team City is there as well, so you don't have to go and read the success. If this is all green, you're good to go. This will be yellow if it's building. As soon as Team City kicks off a build, it'll alert and say, hey, you may want to hold off. The message basically, hold off merging this, or merge with caution. There's a build in progress. So that way you could, that way you can either decide to review it now or review it later. Now, another thing we bundled in with this this recent change to our team workflow is just the nature of our features, because our features get a little bit complicated because they're cross-customer. So we only have there's one code base, this is one app. All of our customers use this. With the best intentions of a feature planned out typically for a single customer with some consideration for the others, it's only really once we're in the nitty-gritty do we really work out what it really means to deliver it. So what we've bundled into this pull request mechanism that helps our testing team and everyone stay in the loop is we basically have markdown files. There's not many of them. They basically form a wiki of the core workflow of a particular feature. Hey, when you do this is the kinds of things to expect. The simplest listing of this is the status that it needs to be in, because our application is really about a workflow and managing statuses of things. So we're doing, as with all sort of documentation, we're doing our best to keep this up to date, but at least at the time of development, at the time of reviewing a pull request, it's one thing we're looking for, and that way at the time of testing, which is a similar time frame, the testers can have a look at this and go, oh, okay, no, they said this thing. Is this what they meant the code to do and the code's not doing it? Or something like that. And then we can always give the feedback of, hey, you missed, I see you changed this. I clearly see that this status variable changed when this thing happens. And in our code base, that's usually quite easy to see. There's an event, and you'll see a status change in the handling of that event, or like a permission change. You'll see those lines, but you won't see an update in the documentation. And there's just a quick example. It's just user clicks. This is the status. Any questions? We can take other questions as well. It doesn't have to be for this session. I know there's pizza. You talk to me later. Yep.
So there is pizza here. What I've done is we put half of it out on the desk out there. So feel free to, if you're really hot.